or do some harmonies.
Awesome. Well, cool. Well, hey, everyone. Thanks so much for joining. My name is Aparna, and today we'll be talking about ML observability. Well, we're going to try to do it not singing this time, but, next time I got, I'll work on it. Brief, kind of overview of the talk today. So I'll go over probably pretty quickly just some of the challenges with productionalizing ML and how we think ML observability can play a part in alleviating that. But the majority of the talk, probably most of the meat of the talk, is going to be around, what you came for, which is really the sauce behind all of the ML observability. So how do I monitor, look for things like drift, performance analysis, data quality checks, and explainability. But just so we're all on the same page, we'll kind of take it from the top. And the core reason for ML observability is that journey from research to production is a really hard journey, not just really big companies, but across, even startups who are trying to put models into production. And a lot of the questions that folks try to ask during this journey is kind of, once a data scientist, let's say, has built a model, exists in a Jupyter notebook, that journey of asking, will this model actually work as I move it into production? Once it's in production, is it doing what it's supposed to be doing? Is it actually working? And if it's not, how do I actually troubleshoot and drill down to what's actually wrong and how do I go fix it so I can improve the model over its lifetime? And some of the common challenges we hear folks struggle with, and especially as these models move into production, is kind of around data drift, performance degradation, model interpretability, how do I explain certain decisions, data quality issues, so especially if there's upstream data pipelines feeding into these models, model readiness, so comparing multiple different versions of these models and really knowing which one you're putting into productions, the best one or the best candidate. And then lastly, in a ton of the more regulated kind of industries that we talk to, fairness and bias issues are a top concern. And so what I'll do today is kind of briefly kind of talk about where observability and kind of monitoring model performance, kind of we've been seeing it pop up and kind of how it fits into the stack. And the majority of the talk will kind of dig in deeper into just what is it, how do you even start breaking it down? You guys have heard a ton about feature stores, and feature stores really do help you kind of handle the offline online feature transformations, maintain kind of really do improve kind of the flow of actually getting that data into production in the same way that you're actually building it. You may have heard of a model store. There's popular tools like MLflow and weights and biases, which kind of sit at this junction of tracking all the experiments and serving as that central model registry, where we see kind of ML observability playing into its roles really as this kind of valuation or inference store that captures all of the online production logs, but also some of the offline kind of records like training or validation, so that you have this holistic picture of what happened in production. Has it shifted or deviated from when it was actually built? And those insights should actually be actionable. So if the model is not performing well in production, are there mitigations or remediations that you can take, such as fall back to an older version of the model or a naive model, or retraining on certain upsampled data sets? And so these insights that are gleaned through observability really should be kind of actionable. And so with that, I'll kind of briefly gloss over kind of where this, what the goal of this evaluation store or it really is to enable ML observability, but it really is kind of tracking kind of these training or validation production data sets stored in this central platform to be able to do things like monitor for data quality, drift, performance degradations using baselines. And then when those things start to degrade or regress in production, providing really granular tools to be able to drill down and do RCA so you can actually improve model performance. And so with that, I'll kind of hop into kind of some of the core pillars around what we actually want to be tracking with observability. And we'll try to touch each of these topics, but if we don't get to them, I'm sure that there will be future talks where we can dive into them. So first up, I'll kind of dive into drift. If you're in ML, you've probably heard about drift at this point. So what is it? Why is it important? Why is there so much talk about this that Dimitri's singing about it? Drift is really kind of measuring this change in distribution. So you may have something like a reference distribution that could be your training data set, it could be your validation data set, and you're really trying to make sure that the data that the model was actually built on or what you're expecting doesn't deviate too far from this distribution as it's kind of sitting in production. And the reason it's important to monitor this is models aren't static. They really are dependent on the data that they were trained on. So if you trained on a lot of data, perhaps with people with really great, let's say, FICO scores, but then you release it into production and you're starting to see a wide diversity of different ranges of FICO scores, that's something to know so that you can actually decide, hey, if my model is not performing well in certain segments or certain groups of individuals, because I didn't train on that set of data, helps you actually know, when does that data actually start to deviate in production and when do you actually need to start taking action on it. And one of the common questions that we get is really around, what is a good reference distribution? And to be honest, it really does depend on your specific, scenario. So most folks typically will use something like a training data set. This is what I built on, this is what I'm expecting to see in production. But we've also had folks do things like, hey, my training data sets actually, I'm seeing this is more of an imbalanced class problem. When I train, I actually, oversample for certain types of classes, but I don't really expect to see them in my production data set. And so, or when I'm actually launched in production. And so in their cases, in a lot of imbalanced classes example, they do things like actually, here's the first 30 days that the model is actually launched in production. Or, let me look back kind of 30 days in production or use some kind of test set. And I want that to actually be my reference distribution to compare against. We also have kind of folks who measure drift across different live kind of A/B tests, different versions of their model to actually see, is the traffic that I'm actually sending to both versions fair? Is one receiving a different distribution than another? And so really the reference distribution that you want to set does depend on kind of what signals that you want to glean from kind of the shift between these two distributions. And I'll give you just a quick example because we all talk about drift, but what does it actually mean? Like, how do you actually calculate it? Typically, what you'll do is kind of, let's say you have a feature in your model, maybe it's purpose of a loan. So you can get a loan for a car, you can get a loan for a credit card. And what you're doing is kind of looking at how much of your distribution actually falls into kind of your distribution in production versus your reference. So let's just say your reference is, the orange distribution, what's happening in production is kind of blue. You're actually looking into how much kind of percent of volume falls into each of these categories, taking the difference, the natural log, and then summing up kind of all of the PSIs across all of these different categories to get kind of one number that indicates what's the total kind of, shift between these two distributions. And PSI is just kind of one example metric, stands for Population Stability Index. It's actually a symmetric version of KL divergence, if you guys have heard of that. But there's a lot of different metrics for how folks actually measure drift. This is one that's proven to be, pretty stable across numerical and categorical distributions, but there's other ways like Wasserstein distance, Jensen-Shannon, and so lots of different approaches for how you can actually calculate drift between two distributions. But drift isn't an end all, it's not a panacea. So it's good for things like noticing, hey, one distribution has massively shifted, or I'm starting to notice some unseen new inputs. So I'll give you an example. Before the pandemic started, these were actually one of the more popular social media or kind of marketing channels, Twitter, Facebook, Instagram, YouTube. And then over the pandemic, we actually saw something like TikTok boom up, and a lot of folks started seeing that they were getting incoming, it was an incoming channel for them. And so this would be an example of something where drift can actually, it's not going to catch things like, ideally hard failures. It's really more for these kind of slow bleed, things are changing over time. Let me catch them. But anything that's related to kind of a single prediction or a single inference at a time. So things like outlier detection, or if you're looking at data consistency between offline and online, if you're using a feature store, those types of metrics are really not meant for drift. And drift is ideally not the right metric to actually catch those kind of insights. But pretty good metric, especially if you don't have actuals or ground truth, to actually get a proxy for have things shifted? Do they need my attention? And with that, I'll actually hop into kind of one of the next pillars. So let's say you're monitoring drift. Another key pillar across the board is kind of performance monitoring of the model itself. We see kind of there's really two different cases that we see. One is there's models that get back ground truth relatively quick after they make a prediction. So if I'm at Uber and I'm predicting something like, hey, here's the ETA that I'm predicting for my ride, maybe within, an hour or so max, I should get back kind of what was the actual pickup time, what was the actual wait time. And so I can get back kind of this fast mapping between here's what I predicted, here's what I was actually able to match it with, join them, and actually calculate performance metrics. But in a lot of real world cases, we see, I'd say we see this isn't, it's not always guaranteed to get back actuals in kind of a relatively near-term window. There's kind of a case where, especially with a lot of, I'd say the lending use cases, et cetera, there's a lot where you kind of have a prediction, will this person, let's say, default or not? And you might not find out for several months afterward that, whether this person actually paid off the loan or whether, there was a late payment, et cetera. And so you're actually sitting there waiting in some cases 2-3 months, et cetera, to actually get back the actuals to map it back to the predictions. In this case, what we've seen people do is use things like proxy metrics. So, were they late on the first payment, or, how much is left on the loan? And so metrics like that to give some indication around how likely is this person actually to kind of match what's happening with what I predicted. There's a second case that we see, sometimes these are not mutually exclusive, but we call them kind of biased actuals, where you may actually make a prediction, like I'm going to decide to approve this person for a loan, or I'm going to decide to deny this person for a loan, but you might only get back actuals for a certain segment of your predictions. And so in this case, only people that have actually said, I'm going to approve for a loan, I'm going to get back any insights around kind of, should we approve them? When we approve them, did they not default? Were we right or were we wrong? People that we decided to deny, they really become part of this unmeasurable set that we really have very little indication about how they're actually doing. Would my model, if I denied them, would they've actually, not defaulted? And so what we've seen some teams do is actually have things like, maybe they have a threshold where they decide to approve or deny, but they, test out, thresholds that are slightly below, just to give some indication around what would have actually happened if we adjusted the threshold based off of user actions. And then lastly, we hear folks around few or very little ground truth, where I'll give you a funny example. There's some folks out there who actually predict things like mortality rates for do I give this person an insurance or not? And in those cases, you can't sit there waiting for years to actually figure out, do I actually need to, am I actually going to be right or wrong about this specific prediction? And so in those cases, they try to corroborate them with other, predictive systems, or actually kind of use, business metrics or KPI metrics instead of actually model performance metrics. But regardless of kind of how you're getting back the actuals, I think the same kind of common principle around, similar to traditional DevOps or kind of data observability, you're not just looking at things like aggregate metrics, like what's my overall accuracy or what's my overall precision recall, or you see, however you're measuring performance for your model, really is kind of looking at specific segments and understanding, maybe my model is doing really well on individuals with high net worth, but on people that have actually recently defaulted, my model is actually not that great on figuring that out, or has really low, poor performance on this specific segment. And so to actually know how to go improve the model performance, figuring out kind of what are the subslices, what are the segments where your model is not doing well, is actually what's going to move the needle on improving performance. I'll go through this in kind of a minute and then kind of wrap up. Bad data quality is probably across the board one of the common things that we hear. And there's different ways that we've seen kind of, people handle this. In some cases, let's say I'm just missing a value. Age is one of my features in my model, and I'm just missing kind of what's the age of this individual. We've seen kind of people handle that in a couple different ways. Either decide to drop the prediction request if it's a really critical feature or important input that they actually need to kind of make a decision. Some cases, there may be some imputation. So let me predict or kind of guesstimate or set a default value that might end up, potentially introducing things like drift or data leakage if done improperly. And in other cases, just, do nothing, kind of let the service handle it themselves. In either of these cases, we've kind of seen there's different consequences, and it's kind of a trade-off to decide how do you want to handle missing or bad production data values. And typically the best way to kind of keep a guard on these is to have common checks on things like missing data, out of range violations for numerical values, cardinality, as well as type mismatch, so that you can actually check if certain features are kind of changing types unexpectedly. Cool. Well, I think we're getting close to kind of the end of this particular session, but there's a lot deep that we can go into observability. Hopefully this gives you guys kind of an intro into all of the depth of the space, and feel free to reach out if you have any questions about ML observability.